We ended the last lecture module by talking about the representativeness relationship. And specifically, we talked about this relationship between a sample and the population from which it was drawn. And we said that under many circumstances, samples can be very representative of populations. They can provide us with good data for the purposes of making inductive inferences about the population based on that data. Now, the representativeness heuristic and formal statistics. So our system 1 inference strategy, our native inference strategy, and contemporary system 2 statistical inference both leverage that representativeness relationship between samples and populations, but they do it in a quite different way, as we'll see. So statistical inference proves reliable because it operates by collecting and analyzing samples so that the dimensions and degrees of representativeness between the sample and the population are stable in their variation. That is, the sample corresponds to the population along known parameters to known degrees. And one of the ways in which statistical practice guarantees this is by making sure that if you want to make an inference about some population, you go to that population and you then draw a sample from that population. And what you try to do is draw a relatively large, randomly selected sample that you then measure methodologically in an unbiased fashion. So when we look at how statistical inference works, that system 2 inference strategy, how it works, we start with this carefully selected sample drawn from the population for the purposes of the inference we want to make right now. We then measure the frequency in that sample and make an inference to the frequency in the population. And that inference also recognizes the variability between our sample frequencies and the potential frequency in the population. And so statistical inference works. It leverages this representativeness relationship using this inferential basis. That is, this well-known representativeness relationship between a randomly selected, reasonably large, and methodologically unbiased sample and the population from which the sample was drawn. We can look at a concrete example of that to help us understand this process a little bit better. So this is based on a poll about the DACA program during the Obama administration. So people wanted to know how the American population felt about whether or not the executive action that established DACA, whether it should be repealed or it should be allowed to go forward. And so this sample then went out to the population, went out to the United States, and it pulled randomly about 1,003 people. And then it asked them this question, and it got this number that 56% felt that the DACA action, Obama's executive order, should go forward and not be blocked. Statisticians and pollsters then made an inference from that sample with its frequency to the frequency in the population. And here, that inference said, my sample is going to provide me with good information for estimating the frequency in the population, but there will be differences, and so my inference will account for those differences. And so the frequency that the poll suggests is in the population is one that ranges from 56%, the frequency in the sample, plus 3.5%, so 59.5% at the high end, to 56 minus 3.5%, or 52.5% at the low end. And so there's this range of possible values. And our statistical inference doesn't say it's 56%. It says it falls with high likelihood somewhere within that range between 59.5 and 52.5. And again, that inference is a pretty generally reliable inference. In fact, we can even quantify how reliable it is because statisticians and mathematicians have carefully worked out these well-known representativeness relationships between randomly selected, reasonably large and methodologically unbiased samples and the populations from which they were drawn. What about the representativeness heuristic? Well, the representativeness heuristic infers the probability of properties or relations in the population on the basis of the representativeness of those properties or relations within the population to one's own internally represented concepts and schemas. And so when we use our system 1 inference strategy, our representativeness heuristic, we don't go and sample the population for the particular inference that we're considering. There are tractability and resource issues that prevent people from doing this for most of human and proto-human existence. It's just too costly and expensive to do anything like this. So what our brains evolved to do instead is to rely upon our experiences as a sample of the population. And remember, since these populations that they're solving problems in are relatively small, relatively stable, and relatively homogeneous, their experiences are probably going to be decent samples. Now, they don't just use experiences with the representativeness heuristic. They use the executive summaries of those experiences, our concepts or schemas. So our notion of what it is to be that kind of thing that we've extrapolated from our experiences with those kinds, or our script about how the world will unfold based on how we've observed the world unfolding in the past. So for example, suppose that I tell you that I own a bird, and then I ask you to estimate the probabilities for that pet bird of mine being a parrot, a parakeet, or a starling. Now, chances are you'll use the representativeness relationship, the representativeness heuristic that is, to estimate those probabilities. And so what you'll do is you'll think about what your typical experiences of pet birds have led you to believe about pet birds. And you'll think about parrots and parakeets, and you might not even know what a starling is. And so you will then say, I think parrots and parakeets are pretty common. Because they're very typical of your concept, you will assume that they are fairly frequent in your experience, and their frequency in your experience will then be extrapolated out to their frequency in the population. That is, their likelihood of being a pet bird of Wallace's. Parrots and parakeets, fairly common. Starlings, not fairly common, though they're a popular pet bird in Britain. Now, in the next lecture module, we'll go through and graphically illustrate the representativeness heuristic in the same way that we illustrated statistical inference. We'll start off by talking about those general relationships in the abstract, and then we'll talk about them using a specific illustrative example. From there, we'll move on to look at how it is that our representativeness heuristic serves us well, the cases where the assumptions hold and the representativeness heuristic is a pretty good inference strategy. And then we'll start to look at the ways in which the representativeness heuristic can let us down, in part because it's being used in ways that violate the assumptions that underlie its inferential relationship.